Concentration and rate law. In the previous video, I went over how the concentration affects the rate. Now, the mathematical description for the dependence of a reaction rate upon the concentration of its reactant is called rate law. Now, rate law expression includes a proportionality constant called a rate constant, denoted by lowercase k. Now this rate constant k, you have to determine it experimentally, and the term for the concentration of each reactant raised to the power its order, denoted by the letter n, can also be determined experimentally. So let's look at this general reaction. Let's say A equivalence of the reactant A produces product. So if I'm writing the rate, it will be, remember, you divide by the stoichiometric coefficients, change in concentration of A over time. Now negative sign is because we are using the reactant. And now this rate can also be expressed in terms of rate law with constant K times concentration raised to the power n. This n is called order and K is a constant, and we determine both these values by experiment. Now let's take any general reaction. For example, let's say if we have two reactants, then what will be the rate? It will be K times reactant 1 raised to the power m times reactant 2 raised to the power n. For example, if I have H2 plus I2 gives 2HI, there are two reactants. So if I have to write down the rate law, it will be K times reactant 1 raised to the power m, reactant 2 raised to the power n. I'm just using these letters m and n to represent the order. Now these exponents m and n are called reaction orders, and overall reaction order is the sum of the orders. In this case, it will be m plus n. And now these reaction orders, they can be 0, 1, 2 or even negative. 0, 1 and 2 are most common. And the unit for this rate constant depends on the overall reaction order, which I will go in a minute. Using initial rates to determine the rate law. So what we do, we observe the effect of changing concentrations. When a reaction is taking place, for example, let's write down this A gives B. What is happening with time? A is disappearing and B is appearing. Or I can say the concentration of B is increasing, the concentration of A is decreasing. Now, if we say a reaction is zero order in a reactant, what does that mean? That means if you double the concentration of A, it will have no effect on rate. So no matter how much A you keep increasing, the rate will not change. If we say the reaction is first order, what does that mean? That means if you double the concentration, the rate will be double too. If you triple the concentration, the rate will be triple too. Second order means, let's say in this case, if you double the concentration, the rate will be 2 raised to the power 2. Fourth, rate will be quadrupled 4 times. That's what second order means. Now, the rate, but not the rate constant, depends on the concentration. This rate constant, which we denoted by K, is affected only by the temperature or by the presence of a catalyst. Look at this question. So you're going to do a very similar question in the lab. I'm sorry, a very similar experiment in the lab. So here we are doing a reaction, and in this one, now this table contains the rate data collected by measuring the amount of product produced per second at a constant temperature. This is again for a generic reaction. So we have A and B both as reactants. So then rate will be equal to rate constant times concentration of A raised to the power m, concentration of B raised to the power n. The question is to find the rate. I have to find the rate of this reaction using this information. So what do I need? I need the value of K, I need the value of M and N, which are orders with respect to A and B. Now, first we have to find the value of M and N, and then we'll find the value of rate constant. Look at experiment number 1 and 2. In these two experiments, if you see, the concentration of B is not changing, but concentration of A is changing. So to study the effect of A, you have to pick the experiments where B is constant. So you can determine how the concentration of A affects the reaction rate, because A changes between these two experiments, but B is held constant. So this is the way we're going to do it. You're going to write down rate for 1 equals K. Concentration of A is, I'm taking this, K 0.0250 raised to the power m. And what is the value of okay, and then we can write down rate 2 also first, equals K, then 0.0500 raised to the power n. If you want, because you can write it down this, now what we're going to do is, let's cancel this right now. What we're going to do is, we're going to do rate 2 over rate 1. We are basically dividing this with rate 1. So what is rate 2? It is 8.16 times 10 to the negative 13 divided by rate 1, 2.04 times 10 to the negative 13. So basically your rate 2 is on the top. It should be m here. 0.0200 K 0.0250 m 0.0250 n. So this cancels out, 0.0500 over 0.0, it is 2 raised to the power m, and here will be 4, 8 divided by 2 is 4, then 4 can be written as 2 to the power second, which means m equals 2. What does that mean, m equals to 2? That means reaction, the rate is proportional to the concentration of A raised to the second order. That means order of a reaction with respect to A is 2. which means if you double the concentration of A, the rate becomes 4 times. We're going to do the same thing for exact same steps, but now we're going to use experiment number 2 and 3. And why is that? Because now we want to find out the rate with respect to B. And why did we pick 2 and 3? Because in 2 and 3, A is constant. And here, if you look carefully, you can just look at the data and you can also tell if we are doubling the concentration, the rate is getting double too, because 8.16 times 10 to the negative third times 2 is this. You can do this whole work, or you can just look from the data. When the rate is doubled, when the concentration is doubled, the rate is doubled too. Then what does it tell you about N? N will be 1, first order reaction, because what does first order means? If concentration is doubled, the rate is doubled. Then can I say the value of N is 1? Now I have a rate. I know the value of M. I know the value of N. But now I need to find the value of K. And how can I find the value of K? For that, what you can do is, so let me write down, there's not enough space. So let's just pick any one experiment. Let's say I'm picking the first one and I'm plugging the values here. For experiment number 1, the rate is 2.04 times 10 to the negative third equals K. Concentration of A is 0.0250 raised to the power 2 times concentration of B 0.0250 raised to the power 1, because N is 1. So if you look carefully, everything is given in this equation other than K. So if you're going to solve K, it should come out 131. And I'm going to write down the unit also. The unit will be 1 over m squared s negative 1. Now again, the unit for the rate constant is different, or it depends on the reaction, what reaction we are using. So here and on the next page I'm going to go over the problem, and that will explain you how to find the unit of the rate constant. It is per second, 1 over m square s. This m is for molarity. So look at this example for the reaction. NO plus O3 gives NO2 plus O2. And experimentally, it is found that the rate is equals to K. NO raised to the power no number means 1. That means the reaction is first order with respect to NO and second order with respect to O3. This has been found experimentally. Then if the question is what is the overall reaction order, then all you have to do is, this is 1 plus 2 equals 3. I'm jumping to 7C. What would happen if to the rate if NO were doubled? The reaction is first order with respect to NO. That means if you double the concentration of NO, the rate will be doubled. What would happen to the rate if ozone concentration were doubled? It is second order with respect to O3. So that means if you double the concentration of ozone, the rate will be 4 times. Quadruple. What are the units of the rate constant K for this reaction? Now rate, the unit for the rate, what is the rate? Rate is change in concentration with time. That is the unit for rate. M stands for molarity, S is for seconds. We have to find the unit for K. NO, concentration of NO. The unit for concentration is molarity, raised to the power 1. Concentration of ozone means the unit for concentration is molarity, raised to the power 2. Now in this I have to find the value of the unit for K. So molarity over second equals K times molarity raised to the power 3. 1 plus 2 is 3. Now I'm dividing with this on both sides. So K is M over M cubed S. This 1 will cancel. So the unit of K is 1 over meter square, molar square second. You can also write this down as, if you take everything in the numerator, this way. So this is the way you find the unit for the K.